With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's start this question. Now in this question we are given the relationship between the osmotic pressure that is given as pi 1, pi 2 and pi 3 at definite temperature when 1 gram glucose, 1 gram urea and 1 gram sucrose are dissolved in 1 liter of solution is. Now we have to give the relationship between the osmotic pressure and define the order for the following pi 1, pi 2 and pi 3. We are given the Van't-Hoff factor I that is equals to 1 for all. Now we are given firstly glucose, then we are given urea, then we are given sucrose. Now these are the three compounds we are given. Now we know that osmotic pressure that is represented by pi is equals to ICRT. This is the formula for calculating the osmotic pressure. This I is the Van't-Hoff factor, C is the concentration, R is the universal gas constant and T is the temperature. Now we are given the osmotic pressure for glucose, that is pi 1, for urea it is pi 2 and for sucrose it is pi 3. And we have to establish the relationship or we have to define the order between these three. Now also we are given the given weight is 1 gram for glucose, 1 gram of urea and 1 gram for sucrose, and their volume is same. Now we will apply this formula ICRT for all these. So pi 1 will be equal to I into C. We will write concentration as number of moles by volume, that is the formula for molarity, that is concentration, R into T. In case of pi 2 it will be I into, this is N1, I into N2 by V RT, this is, and pi 3 will be I into N3 RT by V. Now if we compare these three and we take the ratios, we will get that pi 1 ratio pi 2 ratio pi 3 will be present in the ratio of their number of moles because I is same, that is 1 for all, and we are given volume is also same, that is 1 liter of water is given, and R is always constant, and we are given temperature is also constant. So the ratio will be of N1, N2 and N3. Now we know that number of moles is equal to the given weight over the molecular mass. Given weight we are given 1 gram, and we will write the molecular mass of glucose. The formula of glucose is C6H12O6. This is the formula for glucose, and if we calculate the molar mass using the atomic mass of carbon, that is 12, for hydrogen is 1 and for oxygen is 16, then the molecular mass will come as 180. So it will be 1 by 180 ratio 1 gram. We are given the given weight, and the formula for urea is CH4 N2O. This is urea, this was glucose. So if we calculate the weight, the atomic mass of carbon is 12, hydrogen is 1 and nitrogen is 14 and oxygen is 16, we will get the weight as 60. So it will be 1 by 60 to the ratio N3, that is given weight 1. Now the formula for sucrose is C12H22O11. This is the formula for sucrose, and if we calculate the molecular mass, it comes as 342. It will be 342. From here we can get that the ratio, or we can say pi 1, or we can say in general the osmotic pressure pi in this case will be inversely proportional to the molecular mass. Now the one with lower molecular mass will have the highest value of the osmotic pressure. Now we can see that urea has the lowest molecular mass, that is 60. So pi 2 will be greatest, that is of urea. And we know that the molecular mass of glucose is greater than that of urea but less than that of sucrose, that is 180. So it will be in between these two, pi 1. And at last the molecular mass of sucrose is greatest of them, that is through 342. And if molecular mass is greatest, the value of pi will be corresponding to that molecular mass will be the least, that is this. So this will be the order for osmotic pressures according to the options. It will be pi 2, pi 1 and pi 3. Pi 2 will be the greatest. So option number C will be the correct answer. Thank you so much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.